Assalamualaikum warahmatullahi wabarakatuh. Today, we would like to present our research about cardiovascular disease. So, this is our group members, which is Mohamed Afiq bin Ahmad Sanip, Mohamed Amirul bin Azlam, Faqihah Syazwani binti Abdul Mutaliff, Nur Sahira binti Mokhtar, Siti Nursyaqila binti Mohamed Yusof, and lastly, Rabiatul Adawiyah binti Jawahir.
For our introduction, cardiovascular are a group disorder involving the heart and blood vessel. According to the World Health Organization, cardiovascular rank first for the cause of death globally among any other causes. In Malaysia, cardiovascular have been the main cause of death among Malaysians for 5 consecutive years. These data indicate the seriousness of cardiovascular and the level of harm they can do to a person. We conducted a study to analyze the possible factors that can contribute to cardiovascular disease, such as smoking, the level of cholesterol, and the level of blood pressure. This study is based on the dataset obtained through Kaggle. Based on the dataset, an experiment involving a total number of 70,000 patients has been conducted, in which the result is based on the medical record of the patient. This experiment is done to determine the presence and absence of cardiovascular disease in patients based on the given independent variable. For our study, a total number of 5,999 patients has been conducted and 11 relevant variables have been selected in analyzing the presence and absence of cardiovascular disease in a patient. Based on the World Health Organization, cardiovascular disease are the number one cause of death globally. It took almost 17.9 million lives in a year. Someone that is older tend to have cardiovascular disease, but that doesn't mean someone younger will not have cardiovascular disease. It states that 1/3 of these deaths occur prematurely in people under 70 years old. Taking care of our cholesterol can be helped to prevent cardiovascular. But there are still some of us who never count their calories intake per day because they are too busy with their work. This habit can lead to someone having heavy weight, or it is called obesity. Other than that, consuming too much glucose is bad for our health. To make it worse, when someone have bad habits of smoking and drinking alcohol. Sometimes people smoke 1 box of cigarettes per day and drink alcohol every day.
And for our objective is to select optimal decision tree model to determine the best model of linear regression, to find the best model of artificial neural network, to compare which one has the best overall performance between decision tree, linear regression, and artificial neural network.
For the variables in the dataset, there are 11 variables. Firstly, age. It refers to the age of a patient in days. Height is the height of the patient in centimeter, while weight is the weight of the patient in kilogram. Gender is a categorical variable, 1 if a woman and 2 for a man. Ap high and ap low refer to the number of systolic blood pressure and the number of diastolic blood pressure of the patients respectively. For cholesterol and glucose, 1 if normal, 2 if it is above normal, and 3 if well above normal. Next, for the smoke variable, the patient that smokes is 1 and 0 for the opposite. Alcohol is the variable that identifies whether a patient drinks alcohol or not. 1 if they drink and 0 if they do not. For cardio, the patient suffering from cardiovascular disease is 1 and 0 if vice versa. For the role of the variable, cardio is the only dependent variable out of the 11 variables. Next, we put cardio as our target variable and we reject 2 inputs that are height and weight. Gender, smoke, alcohol, and cardio are binary because it is categorical variable. Cholesterol and glucose as nominal, while the other 5 variables are interval since it is continuous variable.
Okay, we proceed to exploratory analysis. For these 3 graphs, there is no problem with the graph, so no changes have been made. For cholesterol, age, and glucose, the blue one is the frequency of those who do not have cardiovascular disease, while the red one are those who have cardiovascular disease. Alcohol, gender, and smoke are independent variables that is binary input. This binary graph also does not have problem, so no changes have been made. For AP height graph, we can see that there is outlier problem, which is the gap is far from the other data. So we use filter node to overcome the outlier, and as we can see, the gap has been fixed and the data are closer than the previous graph. AP low also has outlier problem, which clearly the graph shows gap from the data is very far. Thus, we use filter node, then the problem has been fixed. High graph has the same problem, which the gap is far, so we use the same method, which is filter node, and overcome the outlier. Same for weight graph, we use filter node to overcome the outlier that made the data has far gap between them.
Before we explain about the process of decision tree that we made, what is decision tree? A decision tree is hierarchical collection of rules that describe how to decide a large collection of records into successfully smaller group of records. In our project, we use decision tree to break the data into the segments, defined by the certain rules each step.
From the ROC chart, we decide that the card model is the best model since the model line is the furthest from the straight line compared to the other model. We have confusion matrix for the model entropy, card, and CHAID. From this output, we can calculate the specificity, sensitivity, accuracy, and misclassification. Based on the table above, we decide that the card model has the best overall performance compared to other models since the accuracy values is the highest with 72.23%.
To identify underfit model, first, find the gap between the trained and valid result of the all performance measures. Then, choose the model with a positive value gap for ROC and a negative value gap for other measures. There is an underfit model for decision tree, which is the entropy model. Identify overfit model to find the overfitted model. Compare the gaps by ignoring negative signs and the large gaps will indicate overfit models. Therefore, the overfit model is CHID. Identify the best fit model. First, filter the overfitted model. Next, we compare the performance measures of the remaining models. Then, choose the model with the highest ROC valid value and the lowest model value. Therefore, the best fit in this model is card model, and our final result is underfit is a trophy, overfit is CHID, and the best model is card. In model evaluation, we did 3 steps to evaluate the model, which is variable importance output, model scoring, and confusion matrix. In variable importance output, based on the result, we can see that the number of significant is 6. This shows that there are 6 variables that have value in the importance column. The most important input is AP height, which is systolic blood pressure, as it has the highest value of importance. For the model scoring, we can see the result based on the English rule from the output of decision tree. For example, we have to pick one data, which is data 235. In note 44, it fulfills all the requirements. For example, we took a look at cardio between 1 and 0. Value 0 is slightly higher, which is 0.60 compared to 0.4. It means that it is a cardio 0. Then we took a look at the app high is less than 129.5 and 120 are included. For age, it must be between 21382 and 12824 and then equal for our data is 21137. We can conclude that it is the best one for our data. The confusion matrix, based on the table, the card model calculate 56.24% positive events to occur, while for negative events to occur, it is 87.78%. In this analysis, the positive outcome is the patient has cardiovascular disease. Therefore, this model calculates patients who do not have cardiovascular disease better than patients with cardiovascular disease.
Logistic regression model is also one of the methods that we use for analyzing the data. It is one of the most suitable models in performing variables with binary outcomes such as 1 for yes or 0 for no, and 1 for good or 0 for bad. An exploration of logistic regression begins with an explanation of the logistic function, which always takes on values between 0 and 1. If the value of logistic function is below than 0.5, it indicates that the result is 0, and if the value is higher than 0.5, the result is 1. For the process in SAS Enterprise Miner, we use 6 models to compare which is the best model. We use LR main, which is the default model, LR interaction, LR polynomial, LR forward, LR stepwise, and lastly, LR backward. ROC chart of linear regression models shows the model line of LR models. Based on this ROC chart in Validate, the value of 1 negative specificity is 46%, while sensitivity is 83%. This chart shows that LR main is the best model because its length is the furthest from the straight line, which indicates the best performance model. For confusion matrix, we need 4 values to evaluate the table. The value that we need is false positive, false negative, true positive, and true negative. So, this is the confusion matrix for LR main, LR forward, LR stepwise, and LR backward. As we can see, the total is 2,323. From the confusion matrix table, we can identify the best sensitivity, specificity, and accuracy of the model. Based on the above table, the LR main model has the best overall performance since the sensitivity and the accuracy values are the highest between the 3 models.
Next, for model validation, we will conduct a table which is contain the value for valid and trained for average square error, mean square error, misclassification rate, and ROC index. All these value for trained and valid we will get in our SAS. In model validation, we will identify underfit, overfit, and best fit model. But first, before we identify the underfit, overfit, and best fit model, we need to calculate the gap between the trained and valid result for all the performance measures. The formula for gap is valid result minus trained results. So, for the underfit model, choose the model with a positive value gap for ROC and negative for value gap for other measure. In conclusion, there is no underfit model for linear regression of the main effect towards a variable selection. Then, to find the overfit model, compare the value of gap by ignoring negative sign and compare the gap value between LR main, LR forward, LR stepwise, LR backward, and choose the higher gap values. In conclusion, the overfit in their linear regression is the main effect towards variable selection, which is forward, backward, and stepward. The last one, for best model, first filter the overfit model, then do a comparison of the valid value. Choose the lowest valid value except the ROC valid value. In conclusion, the best fit for this model is the main effect model. So, this is our result for underfit, overfit, and best fit model. Next, for our estimated logistic regression model, the formula for logistic function is like it. Ln times P per 1 minus P equals to beta null plus beta 1x. This is our table estimated for our best model, which is LR min. From this table, we will substitute the estimated value for each variable into the logistic function, and the equation will be like this. And this equation will be used in our model scoring.
For model scoring, after we substitute the value of the best model, which is LR main, into the logistic function equation, we can calculate it to know the probability of result. So we choose three observations, which is observation 235, 1006, and 2823. For observation 235, the logit is negative 0.4433 and the probability is 0.391, which is below than 0.5. It indicates that observation 235 has no cardiovascular disease. For observation 1006, the logit is 2.2336 and the probability is 0.9032, which is higher than 0.5. It indicates that the observation 1006 has cardiovascular disease, same as observation 2823, which has logit equal to 0.4239 and the probability 0.6044. That shows observation 2823 also has cardiovascular disease.
Artificial neural networks consist of artificial neurons and connections between the neurons, just like the human brain. This is the structure of a typical neural network. Firstly, the input layer. This is where the data enters the network. Next is the hidden layer, where each artificial neuron receives multiple inputs from the input layer. Lastly is the output layer. This layer combines results summarized by artificial neuron in the hidden layer. ROC chart is a graph of true positive rate sensitivity versus false positive rate, one negative specificity. The ROC of ANN model shows the model line of 6 neural network models from the random line. Based on this ROC chart invalidate, the value of one negative specificity is 47.6% and the sensitive value is 84.9%. Neural network 8 has the furthest model line from straight line compared to other models. Hence, neural network 8 has the best performance. This is because the furthest the model line from the straight line and the nearest the model line to 1, the better the performance of the model.
Now, we move to the coefficient matrix of artificial neural network. The table above is to compare the 6 models that we examined in artificial neural network. The table consists of sensitivity, specificity, accuracy, and misclassification. The comparison result is we identify that the modern neural network 8 is the best model in predicting one more data correctly compared to the others model because it has the highest sensitive value. For the cases of predicting negative target correctly, the neural network 3 model is the better model as the specificity value is 0.809 and the highest compared to the other model. The neural network 3 model is also the model with highest accuracy and the best model in predicting classification error as the model has the lowest misclassification value. We move to the model validation of artificial neural network. The table above consists of average square error, mean square error, misclassification rate, and ROC index. The table also provides the gap between valid and trained for each type of validation. Firstly, to identify whether there is underfit or not, we look at the gap of ROC index. From all the model, we can conclude that there is no underfit model because all models are negative value. Secondly, we detect that there is overfit model, which is neural network 11, because it has the highest gap value of average square error, misclassification rate, and ROC index. Lastly, our best fit model is neural network 8 because it has the lowest average square error, mean square error, and highest ROC index for the validation result of all the performance measure. From the analysis we did before, our best model of artificial neural network is neural network 8. From the table, it shows that 66.55% positive event to occur, while for negative event to occur is 76.32%. For this analysis, the positive outcome is the patient has cardiovascular disease. Therefore, this model calculates patient who does not have cardiovascular disease better than patient with cardiovascular disease. and there is 97 number of weight used in the artificial neural network 8 in the fit statistic. For the iteration plot, the last point of the training iteration is 74, which is the mean of the data is a good fit. Next, we proceed to the model comparison of three models. The model involved is cut from decision tree, main from linear regression, and neural network 8. From the ROC chart, the validate shows that the value of 1 minus specificity is 32% and sensitivity is 75%. This is because the model line of the decision tree, which is chart, is furthest from the straight line compared to the others model. The furthest the model line from the straight line indicates that the model has a good performance, which is near to the value of 1. Therefore, the decision tree, which is chart model, has the best performance among the three models.
We have confusion matrix for the last three model, which is decision tree cut, logistic regression, which is LR main, and the last one is the neural network for the neural network 8. From this output, we can calculate the sensitivity, specificity, accuracy, and misclassification. Based on the table above, CAD model has the best overall performance compared to the other models since the accuracy value is the highest with 72.47%, and followed by the LR main, and the last one is the neural network 8.
Underfit models can be found by looking at the gap between trained and valid result of all the performance measures. After that, we will choose the model with a positive value gap for ROC and negative value gap for others measure. There is no underfit model. Overfit models can be identified by comparing the gaps by ignoring negative value or negative signs. Large gaps indicate overfit models in our comparison. The overfit model is an artificial neural network with 8 hidden nodes. We identify the best fit model by filtering the overfit models. After that, we compare the performance measures, which is valid, of the remaining models. Then we select model with the highest value or the highest ROC valid value and the lowest valid value. Therefore, the best fit in this model is the decision tree, which is cut.
In conclusion, the best model is decided based on the variance of the model validation. Therefore, we decide that the decision tree model is the best model to be used between the three models, since the result shows that the decision tree has the lowest average square error and the highest ROC index compared to the other models. Thank you.